So the first few steps almost identical. So you have to copy to your working directory and go to the render, and then from there we can, just sort the script, or you can look at the command and run it, one by one. So here is the script that we have. So I put some extra stuff in here, but the main thing is we load the database, and then we check, make sure, the DSC connectivity. So we did this last time, right? But I just want to give you there's more than just check DSC. There's multiple options that you can run with check DSC. So in this case, we let's say we just want to look at the signal. We don't care much about the power, right? So and then in reverse, when you do floor planning step, you don't want to look at the signal. Then you want to run check only special, right? So um, similarly, for check connectivity, that's if the things that is there with the power grid, we don't really care to look at it. We can just ignore, right? So okay, so let's get a window here. So I'm in my working directory here. So I'm gonna just copy the lab over. And I'm gonna go to render. Okay, that's where I'm at. So just start Innoverse here. You can make sure I got the right Innoverse version as well. So I'm running with this 2232. So Innoverse common UI or stylus, and then we give it a log file name. I'll just call it lab trail, right? So yeah, remember the lab is just more like a guideline, right? For you to get started. When you do the actual lab, you can try different things, experiment with it. So you don't have to go line by line. Let's see what I have here. Right, so we can either source this. So I think I'm gonna do that. Essentially, it's just resorting this export data, right? So if I you go where I'm at. So if I go to this lab trail export. So this is where I'm at, right? We just create that lab trail, right? So it create all these log file, and then that's the run export script. And then this is the export database, right? So we can just go here. I want to source run export underscore, I mean. Okay, so that's where we at. So the first step is we just loading this database, right? And as you can see here, just read DB, right? And then there was suspend. So the next one gonna be check DSC and check connectivity. So I'm gonna type in resume here. Right, so we don't have any DSC, regular DSC, and no connectivity issue as well. So remember last time, we can go in here, and then you can bring up the browser, right? So two way you can do it. That's one way, command base or the GUI base. So I think for this lab, I wanted to focus on the filler cell, right? So we did go to why we need to add a filler in the lecture. So if you look here, just go in and zoom in. So you see here, let's just zoom in a little bit more. So essentially we have all these standard cell placing on the row, right? And not all of them are occupied. So these are the empty area. So unfortunately, the standard cell we have do not have the base layer, so we can't see it. But what you can do is, let's see, just turn on M1. I don't want to look at the signal net. Let's see here. You see those, the row has the VSS and the VDD, right? So that's gonna essentially line up with the VDD and VSS of the standard cell, right? So and then you have the end well and the substrate, right? So what missing here is we have many gap, right? Without the fuel cell, we're gonna have gap in here, right? So the purpose of the fuel cell is filling all these gap, right? So that's thing in the lab. I think there's a command. So it's for we want to determine, let's say, what is the the utilization of the database right now, right? So that's a command. I think this is report place density. Essentially, let's go in and calculate all these many things, but the one that you care about is this one. Right. So if you look closely, the way it calculates is calculate the standard cell area, right? So it's essentially summing up all these area of all the standard cell and then divided by the allocated area which essentially the area of all the row, right? So let's see here. So if I turn off all the cell, right? So let me turn on all the blockers as well. So what you see here are the legal available spaces that can be placed the standard cell, right? So if you turn, you can just turn on and off, and that's how you see all the standard cell has to be placed within this row. So and just to so they tell you the formula here, and I think I have in the lab. Let's see instruction here. I give you like a little bit of advanced, but I think it's good to know, right? Essentially, that's a way you can just get all the standard cell area and add them together, right? So let's do that. Just have some fun. Um, so, so here, because I already typed it here, so let do this. Let's copy it. Hmm. Hope I did delete it by mistake. Hmm. Yeah, sorry about that. Just try to copy this, but can't seem to get it. It's okay, not a big deal. So essentially the idea is you get here, I can just type, get all the instant, right? And you want to qualify with make sure those are the core, right? So for practice, you can do it, slowly. So let's see, let me turn the standard set back on. So here, for it's good practice when you're learning is you can just do this, and then you do select object. Right. So it's select all the cell that you want. So it's like, oh yes, that's what I want, right? It's select all those. Um, you don't want the macros, just the standard cell. Okay. And then look at that, and then we say, well, we just want to look at the area for all of them, right? So that is so when you have a list of the standard cell, you just do a get db on top of it. It's going to give you a list of the area for all the standard cell. Get db. Oh. Right. You see here, every single standard cell get returned a number, right? And there's a math ops function that you can use to just calculate all these. It's a built-in function. You don't have to. Yeah, essentially, it's a sum of everything. And because it's a list, you want to flat it out by using this notation. So do that. So that gonna give you, so this number is the total cell area of all the standard cell, right? And then for the row, same thing. We can get get db row, and you can just say, well, let's select it. That's exactly the area that we want, right? So you select all. So for the row, we could just say, well, I'm going to get the area for each of them, right? So there's an attribute called .rect, which is the rectangular area of the row. So you can do that. So here, I'll do that. Let's see, make sure. So some of these a little bit more advanced, but it's the last lab, so I want to give you something to look forward to. So here, every row has a rectangular corresponding to it, right? So and in Innovus or many tools, they have this function they call essentially you calculate all these area, you sum them together, right? So yeah, they call get compute shape. There's many options you can actually here. It's very powerful. Yeah, it can do all kind of things, right? So take many shape, you can and all these operation you can do, enclose, kind of things. You can increase, decrease all these side x, side y. It's very much you can manipulate all the shape the way that you want. So for us, it's pretty simple. We just want to calculate the area of all those, so we just get compute shape. We want the area, right? And then we feed in that the rectangular. So right. So now we have two numbers, right? So I already have it here. So I just want to show you how to do that. Let's explain. I have everything here. So you can look at this and then it's not that too crazy. And then, okay, so I've, for this, I'll just do the resume. So it's gonna run it for me. So here, actually, I kind of skipped the one. So the first thing is we want to find where, what are the fuel cell in the database, right? So you can just do, I'm gonna just run it here, but essentially you do the get DB base cells, and then you give it pattern, right? In this case, we know it's fuel something. So so it's gonna give us all these, different size, 32, 4, 16, 8. So so what I do here is I just sort them, right? So the difference is what we have here. I just sort them from 1 to 16 because some of the tool, they look at the order that we put in and then it's insert, the first one, regardless of the size, is gonna do it. So Innovus doesn't matter. Innovus you can put in any order. It's gonna look at the big cell and then it try to do the big cell first, right? That's that's usually the case that most people want, right? So you wanna fill the big hole with the big cell first, and then just no more. And then you go to the next cell, right? And then so we did that. And let me do this again. Let's see. Just to make sure. Okay, so after we do the fueler insertion, the density is 100%, right? So, and it should be. Um, so let's zoom in here and see. Okay, so where's the fuel cell? What's going on, right? So remember, we only have this standard cell um, checks here, and from what we learned, the fuel cell is not traditional standard cell; they physical only. So you want to check this box, right? So now everything, all the space has been filled up. Yeah, and so we want to look. Let's see. Turn on the net here. Just zoom in a little bit. Right, so standard cell has some metal in it. Uh, in this case, routing, but the fueler shouldn't have any, right? So, and if you want, you can do, let's say, get DB. I think the default, there's some fueler, I think. I think all of them has the fueler prefix. You can see here, yeah, all of them have fueler prefix. So we can just select them if we want. Let's see how many. So 62,299. Is that what? I can just use this one, probably easier. So I just look at the log here. So right here, 60,299, right? That's what we have. And if you want, so like reviewing all the things that we did before, you can go here. You can, make just have some fun with it. So say those are my fuel cell. So yeah, if you highlight like that, it's very much overwhelming. So all the green one are the fuel cell, right? So okay. And then for some reason you want to do further optimization, you can just say, well, I don't like these fueler. Let delete them, right? So I think that's a command. You can do delete fueler. So sometimes you want to do an ECO and you add new cell. So you have to make room for the new cell to be added. So the first thing you want to do is remove the fueler, right? Or sometimes you just add it in and do the check placement, look at the overlap and see, if you can move just a handful instead of removing over the fueler you know, and then I think, let's see here, put fueler. So that's the list of what we have. So if I'm gonna add, let's try again. I think for Innovus, if I remember, it doesn't matter what order. So let's see, add fueler, base cell. So I'm going to just change the order here, right? So, and I don't think it's make any difference. 16, right? So we just put all these filler in a random order. And the tool automatically do the bigger one first, right? They do the 64 down to 32, 16, blah, 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 right? So the result is exactly the same. So you don't have to sort them. But, let's say synopsis, you have to sort them, right? So cadence is slightly different. Actually, hold on. Let me delete the filler again. I want to see what the area before. The density eval. So before the insertion, we have 56.9%, right? So that's the effective utilization. That's like the real utilization of the dye that we have. And then we can run it again. And do eval. This should give us a perfect one, 100%, right? But if you try this command, actually the funny thing is Innovus doesn't have a good command for this report place. All right, so the tool doesn't actually do it correctly. So here, it's actually give you a little bit more than 100%, right? So so it's good to know how you want to. You can do it by yourself. You don't need to rely on a tool to do it for you. Okay. And it's sometimes um, we insert the fuel cell, and that's gonna be some DSC. So let's check DSC, make sure everything's still clean. Yeah, that's I forgot to do this. So it has one metal spacing, and because I used the same database that we did it last time. So if we look here, so essentially this VSS and VDD, right? So this one, right? So which we don't really care. So you can go here and say, well, I'll just delete them all, and then say, oops, I make a mistake. I'm gonna just do the check only, right? So let's say check only, and you hit tab. So it's give you many options here, right? So by default, it's gonna check everything. So the the two type that you use probably the most are regular and special, right? So special are special net, right? And then regular is everything else. So for now, just say I don't care about the special net, just do the regular one. So it's came back with zero, right? So I think in the final project, you have something similar. So the key is to make sure you use this command, right? Base cell. And I assume it's something like this. So um, you have to find out what are the filter cell, right? And then add them to a list, and then you run that command, right? So pretty simple. Add fillers and then delete fillers, right? So, and I think last time I mentioned that some people do it before the detail route, or you can do it after, right? It's dependent on what type of filler you plan to add, right? So if you add the decap filler, which has metal in it, so more likely you want to do it before, right? So the router actually see it. If you do it after, so once after everything is clean, and then you add in the filler, and then more likely you're gonna get DSC, right? So that's the metal fill. I mean the filler cell. Uh, yeah, here some of these I think we just. Yeah, I have all the note here. So the second thing that we can do for the chip finishing is we say, well, the via, right? So let's zoom in. Look at some of the via. So right here, right, you see most of the, by default, it's just a single via, right? So wherever there's a intersection between two layer, it just put a via at that intersection. So let's do some marking here. So the idea is if we run the redundant via, it's going to go in here and try to convert all these single via into double via, right? So, and look like we don't have a lot of density here. It should be able to convert a lot of them into double via. So let's see. So we have some, let's see here. Right, I'm just add some marker here. So we can go in, double check. So see what I have here. So the command is you route design with the option via off, right? Via optimization. So I'll just do resume. Oh, I did have the delete via, so let me add it back in. It doesn't really matter, but just want to show that you you don't have to do exactly the same thing as what I have in the command. You can do multiple things. Resume. So it's, see here, it's the route detail. And right here, and do the via swapping, right? So try to go in, look at the single via, and try to swap them out. And so whenever you run these commands, there's always a chance to introduce a new DSC, right? So, and most of these commands, they have option to like only do it and then check in make sure there's no new DSC, right? So those sort of things. Um, okay, so it's pretty good. So if you look at the table here, it has a column for single cut, which is the single via, right? And then you have a multi-cut. So for signal, it's very much just double via, right? So it's very good. Very much we get almost 100% due to our design, right? So we look at some of the area here. So let's go back here where we have a marker. So slow, I'm sorry. So let me turn this up so you can see. I think I have a marker here. Okay, so this is where we put the marker, right? So So now if I turn on some of the layer on, so we already see here, they all convert to double via now. So do a few more right here, right? So based on the table here, it's 99 point something. That's mean, yeah, very much all of them got converted to double via. So that's very, very good. Um, so that's one area we can just for the sanity check. We should just hold lay on here. Right. Yep. All of them get converted into the double via. That's very, very good. Okay. Let me see. Curious if I get the same number. 1808. That's pretty good. Exactly the same. 966. 966. Okay. So we did the fillers. We did the VR optimization. And so the last one is metal fill, right? So let's see. So this you can look at the M6 here. We have a lot of area that essentially there's not a whole lot of M6. So this is not good when we send out for to the foundry to make the chip, right? So some of these so like loaner here, these thin metal very much by itself, right? So these more likely gonna be over edge, right? So the width gonna be smaller than it should be. So we don't want that. So let's see. So what's the command again? So usually we don't do within Innovus, right? We have a special tool with the really fancy algorithm to put the metal fill in. But I just want to show you what it's like to add the metal fill, right? So this is not most people don't use the filler within the tool because it's just not good enough, right? But the idea is the same, right? So add metal fill. It's gonna go look at the space and try to add it. And I think that's the option. There's many option too. You can just selectively add some area, right? So there's many option here. And you can do per layer, right? So many options. So for what we try to do here, we just run with the default.
Hey, Dan, I want to elaborate a little bit on why we don't do it using Innovus versus um, third-party tools.
Right, so let's see here. See, so as expected, so let's zoom out. So the reason I look at M6 because we have a lot of space on M6, right? So you can see it's very clearly the metal field get added. And the way, the shape, the pattern is very simple, right? You can set it up too, but so it's not very, it's not optimal. So when we in production, you know, when we have a GDS, we have tool that we can specify with very fancy algorithm to come in and insert the metal field. So it's much more efficient than what we have here within the tool. This pattern is so simple, right? Just essentially square. Uh, and some of them here. So I think M6 is pretty easy to spot. But if you look at, let's say, M1, probably you're not going to see a whole lot, I don't think. Yep, there was not a whole lot. And because of the rail as well. So you want one more layer. Right, so once in a while, you have a big enough area, then it add in piece of metal right there, right? But not a whole lot. And then for the over memory, I think that should be M7, right? Right, you can see here, right? So very much empty space, and
Hey Tim, can you hear me?
yes,
You may explain why it add only a few in Meta Zero versus upright upper layers. There's
uh,
is min and max density requirement per technology. Can you explain that to them?
the mean and max density, you
Right,
said?
right, right. Do metal field there's it checks per area and per there's a min and max density requirements right on the metal. That's why you do metal field. That's why.
Right. So there's a lower limit and there's an upper limit, right? So actually we can do it here. I think there's a check. I think I have in the lab too as well, I think. So you can look at here, check metal field, right? So what this command does is go in and look for square boxes and it check per area and it check the metal density within that, and it's kind of like stepping, right? It keeps stepping all across the die, and with various size, it makes sure that all of those area meet the mean and max. Did did I type it when I check metal field? So what's the command again? Hold on. Oh, check metal density. So I need to correct that in my lab. Okay. So in this case, well, we have a lot of violation here. So let's see. Right. So we can pull up this tool. I think I have it here. Okay. Okay. So let's move over here. So we have 183, and then let's break it down by metal, right? So we don't have uh, all the top layer because we don't have many signals. So the tool was able to go in and put down the metal. Um, so we have no issue. But M1, one thing, let's do 18. Let's do M5 here. So we can just say show only metal 5, right? So if I want, so you see it just boxes. Hold on. Okay, so here, so we have is the actual is 15.8%, and the mean is 20, right? And all these number can be configured, right? So this I'm just running with the default. So the mean is 20, and then max is 65. So the reason it's failing because the mean is only essentially 16%. So so whatever this is M5. So let's see why it's only 15%. Okay, so we turn everything off. We just want to look this one violation here. So essentially, it's just look at this box, calculate all of the metal within this, divide by the total area, and say we don't have enough. And let me turn off the stainless cell. See if that's the case. Yep, it's look very dense, right? But let's see here. Yeah, because we have, look at this. Yeah, we have so many wires small here that the tool was not able to insert additional metal. So, so that, so just a box. Let's see. Yeah, the nice thing is you can show them all. You can hide, selectively. You can pick just a few. So you don't want to look at so many of them. Uh, so that should be 18. It's various size. Right? We have a small one, a bigger one. Okay. Anything else but you want to add?
Yes. So, Ping mentioned there's a reason why we don't normally use endless to do metal field. We all use third party to be exact as Caliber, some other tool. The reason being is because each of the foundry per technology they have uh, the DRC rule deck, right? And what's in the Innovus implementation tool is not complete, it's not comprehensive. So the third party tool actually uses rule deck to check all these DRC violations. So what happened if we use the Innovus to do metal fill? It doesn't see all the rules, so therefore you may be cleaning Innovus, but then when you go to the sign up tool like third party calibers or something like that, then you have a lot more. That's why we don't use Innovus. It basically doesn't have a complete set of rules to do to see. Okay, that's all I have, Tim.
Right. Thanks, Matt. And another thing is when we run, let's say STA and extraction, right? So before metal fill and after metal fill, the timing can be different as well. So for the final timing, we want to do all the extraction after, right? So essentially everything has to be in the design, and then we extract the parasitic, and then we run timing, right? So that's why at the end, it's like it's like you so close, but you're not done, right?
Yeah, so that's very true as you go to lower geometry like 3 nanometers, 4 nanometers, because at lower geometry, wire dominate, right? So what we normally do on a design is we close timing with our metal fill, and then when we do metal fill, you see timing degrade, meaning it got worse. Then we have to go back and do an incremental timing fixes again. So it's a loop in process. So yeah,
Yep.
metal fill have great impact at lower geometry in terms of time integration.
Yeah, sometimes it's so frustrating, right? The thing with chip design is you spend so much effort, and then at the end, let's say you you figure out a way to optimize everything, so your design is very optimal, right? So you fix all the very challenging timing, and at the end you have one DSC, right? Just one single DSC, or and then you have to keep doing it until that DSC is go away, or somehow you have a short somewhere. So sometimes it's very frustrating. So okay, so we at exactly 10.
Yeah, yeah. Can I add before we go? And I know
Okay.
we at the break, but on the topic of metal fields, I wanted to add the tools has something called emulation, right? Metal field emulation, where it's aware of what the metal field is going to look like. So during the optimization in Innovus, it could consider that and predict. So it will help with the minimizing the iteration. That means that minimize the surprises after metal fields are in, right? In terms of timing closure. I just want to make sure that people know that it's called emulation, right? Metal fielding emulation.
Yes. I mean the tool vendor always claim that their metal field is pretty good, right? Every time, but in reality, nobody's really trusts it. It's not good, but not good enough.
Yeah. Again, it's only emulation, right? It just help minimizing the impact.
Okay, so thank you, Phil. So we're gonna take 5 minute breaks, and after that we're gonna do a look at the question you have for the final project, or we can review some material. Hopefully, it can help you with the project. All right, be back in 5 minutes.
Hey Dave, was the time up already?
I think it's up.
10 seconds to go.
Okay.
Oh, oh.
So after it's done, can you add 5 more minutes for the student to complete the poll? So students, initiated the poll again, um, and this time let's take 5 minutes for those of you who didn't respond. So we want to know uh, where we are, um, where you are, and whether or not you find it difficult or easy, and if you have questions and all. So let us know if you don't find the poll. Right. I believe we can share the screen to show. See if I can see it. Share the screen number 2, for example. No, maybe. Never mind. When I share the screen, the Zoom is gone.
I do see it on my screen, but
Yeah. If you don't see the poll at the bar, you see poll/quizzes, right? At the Zoom bar, yeah, you should see it, and you click on it. Hey, Bat and Tieng. So as we answer questions, we might need to bring up Innoverse and all. If you guys can back me up, I'm rusty, so in case I need help, you can jump in, okay? With
sure.
your interactive. So I think for the first part would be the lab number 3 of floor planning, because the lab number 3 has IOs and everything, so it could be a good place for us to show people around. right, thank you everyone for completing the poll. Let me share the result.
And Phil, you're barely audible. Something's went wrong with your microphone.
Yeah, my microphone is pointing to the ceiling. Okay, can you hear me now?
Yes.
Okay, and I hope I'm sharing the right. Did I share yet? You see the poll on the left?
No.
No share. What do you see? Let me share again.
I see your inning Innovus terminal external run.
And on the left is
Blank.
this the poll, right?
No. Blank. I think you're only sharing the. You need to share the screen. I think you're sharing the application.
Oh, I'm sharing the applications.
Yeah.
Let's see.
You need to share the screen.
Okay. I thought I'm sharing the screen. Let me share the screen too then. What do you see?
We see the physical constraint import your slide.
The PowerPoint, yeah.
Yeah.
You don't see the poll?
No.
Nope.
Oh, that's weird. I'm sharing the screen, but it keep on showing the uh,
Yeah. I think I've tried to share the poll before. I don't think some reason the Google the Zoom doesn't allow you something.
We may have to end the poll and then share the results.
oh, maybe that it is. Okay, yeah. Share
The,
result. Uh, but when I share result, I don't know if I just share result. I don't know if you can see it or not.
I can see it.
Uh, yeah, the result doesn't. It's
I
just
think everybody should see the final project post on their screen. So I think you don't
okay.
have to share it here. You can see it, and everybody else can see what's on the Google.
Okay. All right. So it looks like 45 people responded, and the yeah they at least finished the floor plan steps, and one one person finished a basic step. So it's good. Um, and nobody found it easy. 29% find okay, but 13% find it very challenging. And we have half have some questions, and most of them were asked for the TA. Uh, 60% was answered adequately, and 16% or um, not answer adequately. So now we have a few questions. Some will ask in the chat, and some will ask in the classroom, and some will send emails. And small not prefer not to ask. Okay, thank you for everyone. So we have a good idea of where everybody is. So I'm happy to see that all already finished the floor planning. So let's open up for questions.
You can type it in the chat, or you can verbally speak. We're here to help you get over the any challenges you have for the lab for the final project. So let's start with floor planning. Any challenging there? Any questions? Even specific question we can answer. Okay, maybe everybody gone through the floor planning stage. Okay,
Yeah, but I just started to look at the project. Look like the import is very similar to the lab two that we have, right? So if they do the lab, they should be able to do the first portion of
Okay,
the
so
final
I
project,
think
almost identical, I think. Yeah.
I think Ngô Thanh Hao has 4 questions. Okay, how do you choose which kind of cell to add as spare cells? Okay, remember in the believe you add the spare cell in placement stage, right? So you
Right.
want to add normally in the design, you want to add cells that you think you're gonna tend to use. So usually historically in the design, we would add various type of and or combination to ourselves, right? And or and things like that, and then we spread them out. So that's it just random because you really don't know the spare cell is uh for changes, right? For to fix ECO. So you don't really know what kind of cell you need. So you kind of add one of every or a few of every kind and spread it out randomly because you don't know where the ECO will take place. You know what kind of cell you need until they happen. So you try to add uh, two, three of every kind and spread them across randomly across the chip. We uh, we just get that part in placement toward in the placement, right? And then number two, how do I choose NDR in CTS step? So the NDR rules that we discussed were double spacing and double width, right? Those are the two most common one. And then I think we also touch up on perhaps shielding with the ground. Okay, so normally the easiest way or the most effective way to shield a clock net is double space and double width. Okay, I think we did that in the CTS lab, the NDR rules. Um, unless for designs for certain but specific clocks at high frequency that you know that you really need shielding or specific net, then you want to shield it, okay, and you know that by whether you're in your design by design requirements and so on. But if there's not specific requirements, then you probably just default to the double width, double spacing. That's the most common rules that I've used. Tina, if you guys want to add. Okay. Number three.
Yeah, I was looking for the mute, unmute. Yeah, and I guess the student knew why we need double width, double spacing, or why we need shielding, but you probably went over it.
Yes, we went over it, but yeah, so that's we went over that, but we can also remind them, right?
So I'm not sure how the question how I choose NDR, is that the command, or is that how do you determine you need double width, double spacing, or how do you determine you need ground shielding, right? So so I guess I can chime in case it's not clear, right? Why you need double width? It deals with resistance, right? Because the narrow when and electron migration, when you have clock nets switching all the time and very high frequency, very high power, you want it to you don't want the resistance to limit your resistivity, limit your rise and fall time in case that you have sharp rise and fall time requirements, and to meet that, it has to insert too many buffers because of your narrow width. So you want to give it the double width. But that expense of that will be power, because your double width wires will be high capacitances. And double spacing deals with crosstalk, right? Double spacing, if the clock net is an aggressor, if you have signal nets that run parallel to a clock net, the coupling from the clock net can kill the signal and can cause glitches. So to help with that, you space the signals from the clock nets, so that you can reduce coupling effects. Therefore, you reduce glitches. Um, and uh, and if that is not enough, then you do shielding. Shielding meaning you have a ground or VDD running between your clock net and the signal net. So your signal net is completely isolated in case the double spacing doesn't uh, fix the problems. So, all right, I'm done.
Thank you, Phil. Question number 3, in CTS, do we need to set skew and insertion delay target and DRV rules, or just leave it for the tool to auto compute? And Phil, did in the spec, in the PDF, did we have them do that, or we haven't?
No, we leave it open.
Okay, so let me answer in two different ways. So in a normal design, in a real design, you will have target. Okay, you have design will have target skew, target insertion delay, and so on, and also the DLB rules, if usually for the clocknet is much tighter, so you can add on top of what the default is to tighten it up. Um, in real design, but for the class, looks like you leave it for auto compute, and we don't have you don't have to do it. But in the one of the labs, I believe I show you guys how to do it. Okay, but for the project, there's no need since we didn't specify that. So leave it auto compute and the default
and
rules.
and they know the methodology in terms of clocks versus signals, in terms of setting the DRV rules, right? Yeah.
Yeah, yes, oh yeah,
Okay.
yeah.
Uh,
You review the during placement during CS. Those
right.
should be covered already. Yeah.
Yeah. One comment about insertion delay target is that, yeah, usually, yeah, you don't really know how to put that constraints. But if in case you have latency, you need to do certain manipulation of the clock nets going to a memory, for instance, then you control the latency. Otherwise, the skew will determine the latency, unless the latency is too long. So
Okay. Number 4, should we do fill a cap before routing step at the chip finishing? Tim, this is your ball.
Yeah, I think for this design, I think you just do it at the end.
Okay, let me elaborate this a little bit. So on regarding filler cells, so in the lab in this technology that we're using, the 180, so the filler cell does not have any metal in it, metal layers in it, so it doesn't make a difference. But on a lower geometry, their filler cells do have metal zeros in them. So in that case, you want to add them before the routing steps, so you don't get DRC violations once you add them, if you add them later. Okay, so if you add them in there earlier, they have metals, then the router should avoid them and not use that track.
and it might be because even at 180 we have filler cells that have caps in, and they have certainly have devices has metals. I think it's just the PDK here that we're using with Cadence is so simple that it doesn't have it. But there are two types of filler cells, right? One without any devices, and one with the decoupling caps inside. So So make a habit of inserting them before each route step, because they do have an impact on the DRC LVS. Yeah, mainly DRC. Yeah.
Yeah, safest to add before route.
So just one additional comment. So typically you add before a route step, and then you do route optimization, then you have to remove them first. Uh, uh, the reason for that is the route optimization might have to move cells around or add cells. You don't want those filler cells to take up places. You want to leave the holes open for optimizations, and after you satisfy with the result, then you run the filler insertion again to fill the holes again, but this time a different setup of holes and cells.
Okay. Let's go. We have more questions to answer. Wing Jin asked, after route, I have dangling wire arrows. Do I need to fix that at all? So depending on what kind of danglings you're talking about. So first of all, after route, you need to check connectivity to make sure that all your nets connected and the dangling is not related to net list, related to connectivities. The dangling, you can have dangling wires in terms of stub. I think that's going to be flagged as antenna arrows or dangling type when you do verify DRC. So you need to check if it is related to connectivity. That's dangling is not connected. You need to fix it. Um, but if it's dangling in terms of a stub or something like that on antenna, kind of antenna arrow dangling, then that's probably okay. But I would if you need to fix you need to determine what they are first. Okay. Um, okay, and the next one, Micnam High, if the power and CTS layer are not complicated, can we route on these layers? Um, I'm and feel I don't really understand the question. If the power and CTS layer, so the power layers are okay. The power layer can be okay. The power layer should be on
It's
the high of two layers. Um, on CTS
yeah,
layer.
I don't think we limit the layers for signal net, right?
No,
So
but yeah we taught usually on the power stripes you want to be on a higher layer since they're wider they're thicker so they better drive bring your power, but there's no, and then CTS like we want to yeah higher. Can we
yeah,
route these like yeah
the way I read the question is that we have certain layer for power and for CTS. So he thinking that can those layer be shared with the signal net?
oh
Absolutely,
yeah
right?
yeah of
So
course so if the design has 9 layers, by all means open it up for 9 layer unless for our project, yes.
Yeah, I want to add to that, right?
And
So power, right? So if you think about it, power layers are added during the floor planning steps, and after that they're fixed. But if the power grid, as you can see, is not 100% of the utilization of the routing layers. So you do want to open that for any long route or whatever. CTS the same way, right? Sometimes you say, hey, for clock signals, to minimize the resistance, I want to use the upper layers for clocks. So you specify them, but again, the clocks will be routed during CTS step. If usually that's what you do, and then after that, yeah, the layers should be available for generic routing. So.
yeah, for the project, I can think of one scenarios where you there are scenarios where you can't use upper layers. Okay, so if you're doing IPs and there are 10 layers and then the top 2 layers are for power routing for at the chip level, then they forbid you to do those 2 layers, whatnot. So those are the
yeah.
you would
Mhm.
know that by you would know that, okay, they'll tell you. But if they don't say anything like for us for this project, right? You have 9 layers, then open it up for all 9 layers. Okay, we have a lot more questions here. Let's move on. I meet violations in check connectivity after routing. Can you help me fix them? There are
Probably
two
the same thing
violations
as
dangling
the
wire
other question, I
connector right
think.
now connected
Yeah.
together. Okay. Yeah, two violation dangling. Okay, yeah, we have to. You have to bring. We have in that case. We have to bring up your design and see. Take a look at them to see what it is. Okay.
So, but if they do the power planning correctly, do they have the dangling wire or not?
Um.
Because it seemed like these dangling wire is related to the power. Yeah, it seemed to me.
Yeah. I don't recall we have. I don't recall in the run that I did. We have any dangling wire. Sometimes if it's over, for example, when you the via connection intersection, if that one of the step is too long, you'll complain that one segment is one of the path that segment path will be dangling. So we have to bring that up case by to look at it high. So yeah, we can
Or to simplify, we can ignore the dangling
yeah.
errors, right? But the shorts have to be fixed.
Yes, if the dangling wire on the power, the stub, then you can ignore those. Yeah.
Yeah, even on the signals, well, to simplify.
On the signal, it's dangling. For example, if you meet timing and you meet both set and hold time for that particular pass, and you have extra wire dangling, that's fine, and your connectivity is good, then that's fine. Just ignore it. Yeah. So when you say yeah, you if you don't want to see it, you can you can add a dash ignore dangling, of course. But you have to know what you're ignoring. Okay, it's kind of dangerous. Just you don't want to see it, just do a dash ignore. So you have to know what you're ignoring and validate that that is okay before you do a dash ignore, so it look cleaner. Yeah, you can ask questions for student as well. Okay, that's you too. Okay, Phan Trọng Nhân asks, in the routing step, after I route design, I got some error, short metal antenna side error ratio. I ran route ECO command to fix it, but the error is still the same. Can you suggest some way to fix it? Okay, do you want to answer that?
Um, well, it's hard to hmm, short metal. When you have a short and then you run route ECO and it could not fix it, so it seemed like something serious. Because with the design so small, right? We have like only like 6,000 cell. Um, should be able to clean up very quickly.
Well, so the route ECO, are you trying to route ECO? There are, if you want to target specific DRC, there is like option like that's fixed DRC, so the tool will focus on primarily on fixing DRC. So did you see? Did you try that?
Something to do with the power, look like.
So this is a route up metal, short metals, antenna size ratio. Yeah, so this is if it's on the power, the router will not touch it. Okay, the router deal with signal nets. So
So I
to
could suggest, review the power,
yes,
make
look at the
sure it's created, cleanly.
yeah, and then if it's not the power, if it's on the signal nets, then try to target it. Try to dash route ECO underscore ECO dash fix DRC and see if that that's gonna tell the route to focus more on fixing DRCs and so on. Okay, I got arrow none of the base cell specific in CCOP. I assume that's CCOP, not COOP. I assume it's CCOP. When running CCOP design, what is it and how do I fix it? I got some arrow.
I think what it means is that they specify, oh, base cell specified in CCR.
Did you provide the the buffer list?
So
Maybe
CTR would be the
there's a
buffer list,
typo
yeah,
in the buffer list.
inverted list and buffer list, right?
Yeah.
Right.
Uh, so you have to use specific, right? Remember, there is a command to tell the tool if you're not using the right variables. Uh, CTS. Let me see. It is
Yeah, base what he's saying here is they could not find a base cell. That means whatever the list he provide
okay. So
is incorrect.
yeah, so the list should be clock, right? All the cells on the clock cell will be CLK, and BUF is buff, and then CLK INV star is the inverter, right? So you may want to we'll double check. I think what we have is correct. The clock buff and clock inverter. So you may want to check.
In
I can
the
share real
final
quick.
project, you actually list out the CTS buffer list and CTS inverter list, right?
Let me share
So
the screen.
they just have to use that.
Yeah, so this is you guys can see my screen? Hello?
Yes, we do.
Okay, yeah, so this is the buffer list here. You should clock buffer list and clock converters. Okay. So these are the name you should use, okay? And the variables you should this is a variable I use, but there is a set CTS, there's a variable that you set these to, okay? So this is the list you should use. If you use something else, then there's two things. If you use something else, it's not fine, and then you're not using the right variables within uh, uh, Innovus, then it's not going to find either. Okay.
So is that the last one? How to fix whole time?
No, no, I was going to tell the students 1 second. So there is a you need to set db cts underscore buffer underscore cells, right? So that is the I can share it quick here. Help the students. So this is I'll show you here. This is what you need to set, right? So you declare the list and you set it to this CTS underscore buffer cells and says CTS underscore inverter cell. That should tell CTS CCR to use these guys. Okay. Okay. How to fix hold time when finished routing. Okay, so the same way, remember, the so you do op design dash post route. The op underscore design that you can have a dash pre TS, pre CTS, dash CTS, or dash post route. If you do a man, let me show you. If you do a okay, oh, I'm not sharing. I stopped sharing. Okay, student. So you do op design here, right? It has, you can see the post route. So you want to do post route, post CTS dependent station, you post route, you do dash post route, and then you do dash hole. Okay. Without dash hole, it default to a setup. So to fix the post route hole, you do op design dash post route dash hole. Okay.
And you might find that one round is not enough.
Right. So
So
you
so you want to use dash incremental multiple
right.
times, right? So keep in mind, op design without incremental, it will reset everything and do from scratch. But say you run op design dash whole one time, and you're almost there. The next subsequent op design dash whole has to be dash incremental. Keep in mind, and so everything, multiple round after that will be dash incremental.
So yeah, so that's incremental. It'll target. They look only at the violation slack left, and it'll work on that, focus on that versus doing the whole thing again. Okay. So what's the next? I'm sharing, so I lost that. I don't see my. Oh, there's chat. Somebody read. I don't see the chat anymore. I lost it. What's the next questions?
So essentially, he shared some of the picture about the dangling wire. So I open up what he shared. It's not too detailed, but based on the. So maybe I can share. Actually, let me share. Let me share screen here. Oh no, where is it? So very. Okay, here. Okay, you guys see my screen?
Yes.
Oh, so essentially this is the picture that Vũ Quang Minh uploaded to his Google account. So I noticed that he has a lot of dangling wire here. So it's it's not too detailed, but I'm guessing that essentially there's a gap between the memory. So when you create the row, right, you want to make sure that you don't want to have like that tiny, very short row that can't essentially there's no power can be connected to that M1, right? So those M1 are essentially floating. Uh, so you make sure you optimize, you get all these add blockages to make sure this you don't want to place cell here anyway, right? So on these tiny gap. So so just zoom in those area and see if those tiny M1 are floating. Is anything connected to that M1? More likely there's none.
Or your M1 might not be connected to the stripes. So check the vias if the M1s are via up or not. Yeah.
Okay. So in my design, I did check connectivity. I ran the lab. I have in my completely round op design, I have one dangling net, which is on the VDD on the right upper corners. That's it. It's just a little segment that over the wire on the video connection, but nothing to worry about. That's it. Okay. So yeah, so look like there's
Yeah, just review the macro placement and the blockages, right? So yeah, turn off all the standard cell and see where the rows are, right? If those rows are very short,
so
completely you don't want those. Just block them out.
yeah.
Yeah, look like a lot of students having the same issue. I think yeah, just review the macro placement I try to optimize it, right?
Um,
Shove into the corner, you know. Yeah. Just essentially don't have the tiny gap between around the macros. Yeah.
so we can, let me show you. Hold on, let me zoom in.
Is there more question?
So his is around the macro. So okay, so look like what happened. Look at their rows probably. So student, did you not put a halo around it? Look like that picture there. If you put a halo around it and it should extend to the boundary. So there's no row. Even if you have row, you put a halo over it. It doesn't route M1 underneath it. So you have a M1 route there. There's no standard cell and they're going to be dangling, nothing connect to it.
Yeah,
Okay, so
that's a good guess. Yeah, check the halos.
um so if you look at, let me see the halo here. Okay, so here, let me share a quick student. Let me show you what they're talking about. Okay, you guys see my screen?
Not anymore. You
Okay.
just
Let me know when you see it.
okay. Now we see it.
Okay, so this is the macro, okay? So if the macro edge is right here, this is the die bound, the core boundary, right? If you don't put a halo here, so what happened here, if you don't cut the row either, you have row here, it's gonna put the routers on special route, it's gonna put metal one across here, and it's gonna be dangling, right? If you don't have a stripe coming in, okay, then it's gonna dangling. So you need to put a halo, block halo in, like I did. So it'll block it off. So there's nothing there. It cut the row and everything. So it won't place a metal one power there. So you don't have the dangling issue. Okay, so check that. Okay. Any more questions? Okay.
That's the op design. That's whole post
It's a
route
halo is too thin, so there's
incremental.
space between the macro and core boundary. Yes. So if it's too thin, there's space, and increase your halo or move your macro over. Okay. If you have room on that side, just either increase your halo, or it's easier to increase the halo to block it out and cut your row. Yeah. Okay. We have 8 minutes. Any more questions? If not, we can review each stage. So let me think. And Phil, do you have anything? We can start with placement. Do you have anything to review for placement step? If not, I go to placement.
No, I only have reviews for up until floor planning, so you can do whatever.
Okay, so let me quickly review what.
So I think a lot of them missing the halo, right? So
Yes, so you need.
or the halo is not large enough to cover the tiny gap around the macro. So
Yes, especially on the backside, on the edges that along with when you place your macro, you need to place it near the edge. And then when you halo, you create a halo, it need to fill that gap between the core die area versus the backside along the edge of your macro. Yeah.
this is actually it's a good practice to place your macro, you know, like X micron away from the boundary, right? Let's say 2 micron. Yeah. So you can use the floor planning tool to do that. So you can like know ahead of time, I'm gonna need the halo to be 2 micron, right? So instead of using just moving using the mouse. You can actually use the tool to align those, and so you get the exact 2 micron, right? So everything fit perfect.
You can do you can use hard blockage, but there's no reason because the halo is automatic, right? So
So
the
lady, I'm asking how width is good? What multiple times of the site? Are you talking about the width of the halo, or if you're talking about width of halo, is there is no I mean it's good if it's you cover up um the gap that you need. Okay, so it's case by case, so it's not a hard number. Okay. So next question is, in this project, we don't need to use ICGL. So in the project, the ICGL is already there. Okay. So if you look at the beginning of the CTS during that diag, it'll already show you. I think there's 36 cells. It's already instantiated in the design for you, in the netlist for you. Okay. So it's already in the part of the design. So you don't have to worry about ICG cells. It usually is already added in there for you. Okay, next one is when I run command check connectivity, a lot of arrows about special Y. Okay, so it looks like most of you guys have the same issue with the placing the memory on the backside. Oh, let's see. Wow, this is something. So you guys see the screen I just brought up? You guys see the check connectivity screen?
Yeah.
So this is grossly something went wrong. Okay. So
Yeah, look like the rows are not connected.
yeah, they're not
Missing
connected.
VR. Yeah.
Look like the metal ones pound grounds are not connected to the upper layers, so it's open. It's not via up. Yeah, so you have major issue on your power ground. Remember, you remember the sanity check. You should have caught this before you gone this far. Okay, so let's review. In the sanity check, right? Where was this? Okay, so here's sanity check in placement, right? One of the check is all pound PG nets are short free or not open. Yeah, no open, no short freeze, right? So you make sure at this stage your pound grounds is good before you go on, because when you go on, your pound grounds in, you have to go back, so you waste a lot of time, a lot of cycle time doing things. Okay. So in placement, make sure that you check all this clean before you go on. Okay. So this is one important check.
yeah, can I share the screen to help answer that question as well? Let's see. Now oh, okay, you can see the stress screen, right? So when you create the ring and the stripes, there are the set dB that you can specify the top layers, the bottom layers. So these things will affect how the stripes are veered into the grid. So do check your set dB to make sure that it fits your meta 6 meta 1. What it means that when you create a stripes, if you say meta 6 is top and meta 1 is is a bottom, then when you have a stripes going across or going vertical, where it intersect, it will connect from metal 6 to metal 1. If you don't have this, and it default to something that you don't have the connection, so you have dangling floating wires. So each of these coring and block ring, there are set dB that you want to review and make sure that all the layer settings are correct. Okay.
Okay. So if you need more additional on the S drive, just do a man on it, man page on it. It'll tell you what's how to do that cross via the metal the V up and Phil was just talking about those are called cross vias. When basically yeah when it goes up stack vias. Okay. What I guess we have 1 minute. So there's really not much time left.
Is it possible that if they couldn't figure out how to how to debug it, they can save a database somewhere, and then if we have time, we can look at it.
Well, your first support line for them will be the TAs, right?
Right, right.
Yeah. So get with your TAs. If can't resolve, then just shoot a message to the send it to the streams in the classroom. That way, if we resolve it, they can share with everybody else also.
Yeah, and to do what you thinking, Tian, um, we can talk to Phương and have him set up a server where the students, we're gonna need to do this for submission anyway, because right now we cannot see their home directory, so we can enable that new server so the student can upload their database in that server where all the instructors can have access to. So we can do it that way. So this week when we meet with a bigger team, then we can ask for that. I will submit. I will check with Phương to see where he is in terms of setting the new servers for the instructors. Right?
Yeah, yes. So when we do this, until I think we probably not gonna have time to do take every individual, but I think we can see what are perhaps we'll need TA's help. What are some, what are the most challenging, the top few, and then we can take that and then show the student how to do it, and that way they can do it. They can do it on their own.
Yeah, I completely agree. Yeah, yeah, 100%. Yeah. Uh, these only the areas that the TA cannot solve. So, but most of the problems the TA can solve, right? Yeah, please go to your TA first.
Yeah,
And
the
yeah,
the
and
big
TA.
the biggest issue so far is related to that the follow route, right? So the M1 look like so.
So, before you go on, I think you will not have enough time to complete the project due to various reasons, right? And the servers being available late is one of the reasons. So we are thinking about postponing the deadline or the due date for the project. So um, yeah, try your best, and so that you can can be ahead. But we're gonna announce a postponement. On Friday. We're gonna see what makes sense, what the final due date would be. So almost certain that we're going to extend it past the 19th. But if everybody can solve the problems and can submit before the 19th, then we won't have to postpone. So let's see where you are on Friday.
please
Okay.
please keep on going, okay?
Yeah, please keep on going strongly.
Okay, I'm done. Go ahead. You have the last word.
No, I think that's it, right?
I'm done. All right.
Okay, well, keep on. Yeah, keep your question coming. In the next session. Okay, bye.
Yeah,
Okay.
and use Google. I really am impressed with a lot of good questions on Google Classroom, the stream. So between now and Friday, if you have more questions, please post them there.
All right. Thank you.
All right.
See
you
you
guys
all on
Friday.
Friday, right? Yep.
Yep.
Bye.
Okay.
Bye.
Bye-bye.
The recording has stopped.